Today we shall work out some typical problems on Rolle's theorem and mean value theorem. The first problem I am taking the application on Rolle's theorem. So to work out this problem, first we state what we mean by Rolle's theorem. What are the conditions of Rolle's theorem? Number one, if a function fx is number one, if a function fx is continuous in the closed interval, fx is continuous in the closed interval a less or equal to x less or equal to b. Number two, if dash x, the derivative of fx, that is the dash x, exists in the open interval, exists in the open interval a less than x less than b. And the third condition for Rolle's theorem was value of the function at the two extreme points, that is fa equal to fb. If this condition holds, then there must exist at least one point c, at least one point c in a less than c less than b, where f dash c equals to 0. Where f dash c equals to 0. This is the condition of Rolle's theorem. Statement of the Rolle's theorem was this. So how we apply this theorem? So what are the conditions? Number one is fx is continuous in the closed interval. Number two, if dash x exists in the open interval. And the third one is the value of the function at the two extreme points, that is a and b, if a equal to b should be equal. So this implies there exists at least one point c in between a and b, that is in the open interval a and b, where f dash c equals to 0. So application of Rolle's theorem, I have taken a problem. Let a0 plus a1 by 2 plus a2 by 3 up to a by n plus 1 equals to 0, where ai is the real constants. Prove that the equation a0 plus a1x plus a2x squared up to nx to the power n equals to 0 has at least one solution. There is one root in the open interval 0, 1. So first we consider the function. Let us consider a function fx is equal to a0x plus a1 into x squared by 2 plus a2 into x cubed by 3 plus 1 plus an by n plus 1 into x to the power n plus 1 by n plus 1. We have considered the polynomial fx is equal to a0x plus a1 into x squared by 2 plus a2 into x cubed by 3 plus 1 up to n into x to the power n plus 1 by n plus 1. Now we shall apply the Rolle's theorem on this function. So first condition should be satisfied first, as because fx is a polynomial in x, so fx is continuous in the closed interval. Fx is a polynomial. This implies fx is a polynomial in x. Polynomial in x. So it is continuous. This implies it is continuous. Every polynomial is always a continuous function. So it is continuous in the closed interval. Continuous in the closed interval. We have taken the interval here as 0, 1. So 0 less or equal to x less or equal to 1. And f dash x. What is the f dash x? If we differentiate this, a0 plus a1 by 2 plus a2 by 3 plus 1 up to an by n plus 1. If dash is equal to a0 plus a0 by a1 by 2 this into x plus a2 by 3 this is a2 by 3. If we differentiate this, so this is our a2x a0 plus a1 into a1 into a1x into 2 this into 2 into a1x by 2 plus 3x square a2 by 3 into x square and so on n by 1. This differentiate n plus 1 and cancel. So this is, if we differentiate this, n plus 1 into x to the power n. So you are given that, so this is equal to. So if dash is equal to, what is our if dash 0? So if dash 0 is equal to 0, if dash 0 is equal to 0, and what is our, f0 is equal to 0, and what is our f1? f1 is equal to, you have seen that this derivative exists in the open interval, this derivative exists in the open interval 0 less than x less than 1. So first we have taken a polynomial. If the polynomial is continuous, which is continuous in the closed interval, then derivative a0 plus a1 into twice x by 2, then a2 into the, if we differentiate this x squared by 3, this is our 3, 3x squared is a2 plus so on n into n plus 1 into x to the power n by n plus 1 and n is to the power. This exists in the open interval. Next we find the extreme point, the value of the function at extreme point, and the one is f0 equal to 0 and f1 is equal to also, f1 is equal to, if you put x equal to 1, what do you get? a0 plus a1 by 2 plus a2 by 3, a2 by 3, this up to n by n plus 1, up to n by n plus 1, and we know that by the given condition, this is equal to 0. So we can write that f0 equal to, therefore we can write f0 equal to f1. So the three conditions of Closed theorem are satisfied. Number one, fx is continuous. Number two, f dash x exists in the open interval. And number three, this is the if a is equal to fp, that is f0 equal to 1. So what is the conclusion? There must exist at least one point between a and b. Here, what is our a and b? So in between 0, 0 and 1, there must exist a value c which will satisfy the given equation. That is, so what is our, that is c0 plus c, not c0, this is our a0, this is a0 plus a1c plus a2c square up to an c to the power n, this equals to 0. There must exist a value c when f dash c equals to 0. So f dash c equals to 0 means f dash c, this is equals to, there must exist a point f dash c equal to 0. So from this, so this implies, this will imply this equal to 0. From this, we can say that c is the root of this equation. Therefore, we can say that c is the root of, c is the root of, c is the root of the equation. Here you are given, there is the root, c is the root in between of the equation. So the root of the equation. What is the interval? In the open interval 0, 1. So root theorem has verified, and this has at least one root. We want this. So what we have done? We have taken a polynomial. First condition we have shown that it is continuous. and second condition is derivative exists and in the open interval and extreme point the value of the function is equal. So at least one point C in between this interval here, the interval is 0, 1, find that derivative is 0. So we have seen that this equation is at least one root this. So the details of this example is given in the next page. The details of the solution is given in this page. Next we come to a problem on the application of mean value theorem. So, mean value theorem, we should first state what we mean by mean value theorem. The statement of the mean value theorem, first we state it. What is the condition of the mean value theorem? Number one is that first condition was fx is continuous in the closed interval a less or equal to x less or equal to b. Number two, f dash x exists in the open interval. Then there must exist at least one C in the interval a less than c less than b, such that if b minus fa by b minus a equals to f dash c. This was the statement of the mean value theorem. So I have taken the problem. If fx and dx are two differentiable functions in 0 plus equal to x plus equal to 1, such that you are given x0 equal to 2, f1 equal to 6, g0 is equal to 0 and g1 equal to 2, so that there exists c in between 0 and 1 such that f dash c equal to g dash c. First, we shall apply the mean value theorem on the function fx, then on gx. So first we have stated the mean value theorem. So if we want to apply the mean value theorem on the function fx, here every differentiable function is continuous. So you are given that fx is differentiable. You are given that fx is differentiable in this interval. Every differentiable function is always continuous. So this implies fx is continuous. This is continuous in the closed interval. So these two conditions are satisfied. Number one, fx is continuous in the closed interval. F dash dash exists in the open interval. Then what is the statement? There exists at least one c such that here we have taken the interval 0 and 1. So there should exist c between 0 and 1 such that fb minus f means f1 minus f0 by b minus a, that is 1 minus 0, must be equal to f dash c. What you are given? f1 is equal to 6 and what is the f0? f0 is equal to 2. So this implies f dash c equal to f1 is equal to 6 and f0 equal to 2. So this is our 4. Similarly, you apply mean value theorem on the function. Apply mean value theorem on the function dx. Mean value theorem on dx. So what do you get? You are given gx is differentiable and so it is continuous. And what is the statement? Gb by mean value theorem on dx. What do you get? g1 minus g0 by 1 minus 0. This must be equal to g dash c. So this implies What is our G1? G1 is 2. What is our G0? G0 equals to 0. So this by 1 equal to G dash C. So this implies that G dash C equal to, so G dash C is equal to 2. Equal to 2. So from these two results, F dash C equal to 4 and G dash C equal to 2. Therefore, you can say that F dash C is equal to, therefore you can say that F dash C is equal to 2 into G dash C. So we have to show that F dash C equal to 2 G dash C. Again, I will explain this. You are given two functions fx and dx are both differentiable, both are continuous, and so these two conditions are satisfied. So mean value theorem stated that if b minus fa by b minus a is equal to f dash c. So we apply mean value theorem first on the function fx in the interval 0, 1. So we have got f dash c equal to 4. Then on the function dx, that is g1 minus g0 by 1 minus g0 equal to g dash c, that is g dash c equal to 2. From these two results, we get f dash c equal to 2 g dash c. So the details of this problem I have solved in the next page. Thank you.